All right, hello there. This is Justin Rondo here, and in this video, I'm going to go over the actual settings for GPower 3 and how I use it. So this is a pretty intense statistics calculator here, and I don't want you to get lost in kind of reading through their documentation, which is pretty intense, nor do I want you to kind of use the wrong setting so that you get incorrect data. So let's just jump right into it. So first thing you want to do is pick the correct test family. And VWO and a lot of testing texts are based off of z-tests. So select z-tests. You don't need to know what a z-test is, what a x squared test is, what a t-test is, what an f-test is, what an exact is. Just go to z-tests. That's what we're working with here. Okay, so now you need to get to picking that statistical test, the one that we'll be using. And in this case, we're using proportions, difference between two independent proportions. Okay, we don't need logical regressions. We don't need this is all it is. I'm going to teach you in this video just the input parameters that you need to run these. Okay, so once you have these two things set and in place, now you have the choice of the type of analysis you want to do. So you have a priori, which will compute the required sample size. So this is very useful to see if you have if your page can actually be tested on, and what's required there is your desired confidence rate, your statistical power, and your effect size. So what the lift you'd expect to see between the two proportions. Okay, so let's go through that one first. All right, so we have a priori set. So let's go to tails. It needs to be set to 2. All right, and the only other change we need to make on here right now before we dig into proportions is our statistical power, which is 0.8. All right, so let's take a look at our proportions. Now, a 50% conversion rate, that's absolutely massive. So let's not play around with that currently. Let's put that at a 10% conversion rate, all right? And now let's say you want to get to a 12%. You're expecting to see a 20% lift here, all right? So then you can go to calculate, which is kind of taken off at the bottom, but you go to calculate, and then you get these output parameters here. So this is saying the critical z, which is at the level of 0.95%. So that's fine, or at the 95 percentile, what we'd expect. So then this will just tell us the sample size required for this page. So for each group, you need 3,841. Total would be 7,682. So if you don't have a page that in about a month to 6 weeks can't get 7,682 people at it, then you can't run this test. Or again, we had some other options for playing with the numbers. We could drop this down to 0.1, which would be a 90% confidence rate. We'll hit calculate, and that gets us down to 6,052. So maybe that'll work for you, but there's a higher level for error there. There's a chance for a type 1 error. All right, now let's go into a different type of test. So this will be compromise. This will compute the implied confidence rate and power given the ratio of change, the sample size, and the effect size. So here we are. I don't use this one all too often because this is actually what's in the testing tech. All right, so it's two-tailed. Let's keep our proportions 0.1, 0.12, and let's do our sample size groups at, let's say it's at 2,000. So let's say maybe we only have 4,000 people hitting the site in this case. So this is going to tell us at this rate what we'd expect to see. So at an average error, so the average error probability, so the confidence level here is that says 0.14. So that is just at the 86% confidence rate. So that's sub 90, which you should start being a bit suspect about. And this one is at sub 80, so at the statistical power side. So you wouldn't want to run a test where there's only 4,000 here at a 20% lift. You'd either have to get a higher sample size or a better proportion. All right, so let's look at criterion. So compute required confidence level given power, effect size, and sample size. All right, so this will tell us the actual confidence rate here. So in this case, let's change this now to, we know we can't do it with, let's do it with 2,500. Oops, 2,500. We knew we can't do this with a 2,000. All right, so let's calculate it. And so this is still sub 80. This gets us to the 85% threshold that's occurring here when there's a 20% lift in a two-tailed test with 5,000 total sample size. So this is just telling us the actual confidence level that we could expect from those numbers. All right. So now we have post hoc, which will be compute achieved power. I don't use this one ever, so let's actually skip that. And then sensitivity, which I think is actually one of the most useful ones that we have here, which will tell us we have proportion 1, because generally we don't know, unless we're looking at a completed test, we don't know what the effect will be. We don't know at what percentage it will either the lift or the loss will be at, or even if there will be a lift or a loss. So in this case, this will tell us what we need to see at minimum to hit the numbers that we're looking at. So let's actually put this back to 0.05, so at a 95% threshold. Okay, and let's have our proportion still be, let's make this 20% now. And let's say our sample size is 3,000. 3,000 for each variation, so 6,000. Right? What would we need to get for proportion 2, minimally, for us to be able to run this test with this sample size? Okay. And what we'd need to see there is just over a 10% lift is what we'd need to see. And if we can't expect to see a 10% lift on this page, maybe because it's already been uber optimized, or it just you just don't see it happening, then this is a page that we can't really run tests on unless we can increase that sample size. So I think here, when we're using this calculator, the most important ones that you could have here would be compute required effect size and compute required sample size. The other ones are kind of done within other texts, but these ones I think will really help you from a scheduling perspective. So if you're really just kind of in the mode of, can I test this page? If I can test this page, how long should I be testing this page? These are the two ones you want to use. So sensitivity will tell you if you can from a lift perspective, and then a priori will tell you from a sample size perspective. So I really, really hope you guys download this tool and use it. Let me actually show you what the web page would look like. So GPower 3. All right, and you are not in the wrong place when you go here to the all right, you'll see that's a Universität Düsseldorf, and you'll see the screenshots. You should be used to seeing these by now, and you can download it. It is free, and I really, really, really stress using this when you're scheduling and prioritizing your tests. All right, well, enjoy and happy optimizing.